So please go easy on me. This talk is on software architectures, specifically the circuits Python framework. So circuits is a Python framework. My name is obviously James Mills. I'm also known on the web as Prologic. You've probably seen some of my repositories and Python packages that I may have contributed to. I'm a Python web developer. Pythonister, if you want to call it that. I do a lot of work in the web space. Open source enthusiast, obviously. Proud father, and those sorts of things. You'll have to forgive me. I probably shouldn't even do this. I actually can't see that well. I'm vision impaired, so I'll try not to talk to the slides as best I can. That's better. So some of the things that I've done, recently I've worked at Griffith University. I've had to recently change jobs because of contractual issues, restructures, that sort of thing. I worked on two major systems there, the Terra Nova content management system, which is basically written in Plone with a lot of custom packages. Plone itself is actually built on Zope. I'm sure all of you are familiar with Zope as a component architecture. And I've also worked on another sort of side project along that called the Climate Change Adaptation and Visualization Tool. It sounds like a bit of a convoluted name. It's essentially a climate model data browser for big data that gets churned out of high-performance computing clusters. I've done various other things over the years, wikis, content management systems, IRC bots. Everyone's written an IRC bot. What is Circuits? As I just alluded to before, Circuits is a Python framework. It has no external dependencies. It's all written in pure Python. So there's no C extensions to compile when installing it. You can pip install Circuits, and it should install pretty quickly. Probably most importantly is that Circuits is a component architecture. We'll cover a little bit more on that in the next few slides. It's event-driven. Supports asynchronous I/O and coroutines. It's probably always supported asynchronous I/O, but that's not the space that Circuits really sort of competes in. It's more around architecting software and trying to create more maintainable software. Circuits also has a web framework and plays nicely with other libraries and frameworks, including Tornado, Twisted. Recently, I've done some work in actually integrating Circuits with Twisted. That is to say that we can actually run Twisted protocols and applications on top of the Circuits framework. I actually can't see the titles of these slides. I shouldn't do that. All right. I'm pretty sure that slide says something about component architectures. So a lot of this has been borrowed from the Track project. Anyone that's been in the Python space for a while has probably heard of Edgewall software and the original Track project management system. It was probably one of the nicest component architectures I've ever come across. And a lot of the definitions I've taken have been borrowed from there. So a component is an object that basically gives you a service of some kind, wraps up a service. They're generally singletons, but they don't have to, in my opinion. Circuits did support singletons a while back, but we removed it because, well, if you want to do it, you can do it yourself. So essentially, components is all about interaction between various components in a loosely coupled way, and the definition there that has been liberally borrowed from the Track website is one that I sort of like, but I like to simplify it a little bit. So components are essentially a way of declaring extension points and then extending that component without the other component knowing that it was extended. So here's just a little diagram that was also taken from the Track website, which sort of illustrates the point. So you have a component on one side and declaring an extension point, another component on the other side that sort of extends that component, but the two components don't really know about each other, and you might have a third component. So when you start to treat everything as components and the interfaces between components as events, which is what circuits uses to declare various things that can occur between components, you start to end up with a bit of a nice way of structuring your application and extending it, depending on requirements, changes, and all that sort of stuff. There are some other similar projects. Zope is a component architecture. The Zope component architecture, as it's called. There is a couple of others. I've not actually really used any of them. There's PyPass, I believe, but it looks like it's dead. Kamaelia, I believe, is still actively developed. And one other one, which I can't remember the name of. If you look up Python concurrency in the 99 bottles of beer on the wall on the Python wiki, this is where some of these examples have come from, so things that look a bit componenty. Okay, so just a little bit of background on circuits, where some of the name came from. So the name of circuits was chosen to sort of be a little bit analogous to building electronic circuitry. So you can think of components as your sort of a breadboard, events as signals between components, and that sort of thing. So that's sort of where the names come from. So you've got circuits, the framework, components, events. It's pretty much where that name has come from, and it's sort of stuck for quite a number of years. Just a little bit more about the history. Circuits was originally inspired from my undergraduate days, about a decade or so ago, by the late Professor Jeff Dromey, who taught behavior trees and genetic software engineering, which sort of is a little bit like, component architectures. Sadly, he died of cancer a number of years ago. I won't go into genetic software engineering or his work in behavior trees. Feel free to look that up. That's where some of the inspiration came from. It originally was actually written in Java. So the first prototype of what the circuits framework was actually written in Java a long time ago. So we've been developing it since 2004. A few people in the community that do discover circuits often ask me why it's not as not more popular than it should be. My answer to that is because I'm an engineer and I suck at marketing. Yeah, so we've seen a number of contributors. I'm not the only guy on this project. It's not just a one-off thing. It's been around for a while. It's been used in a few different places. Some people use it for web application development, which you'll probably see in the next slide, I believe, with various contributors. Myself, Alicio has probably been one of our biggest contributors, along with Michael Lipp. Justin Grigori from the US, he uses circuits quite extensively to build his web applications for a lot of his clients. A few other people that I probably actually can't see from here, and the memory eludes me for now. This has been taken from Mercurial's churn. So these are all the people that have contributed, either extensively or a little bit more than one or two commits or bug fixes. So this is what it looks like. If I can just highlight, yep. So this is your classic Echo server. You've probably seen examples like this from Twisted, maybe. I'm not sure I've ever seen a Tornado one. So a bunch of imports at the top. The first thing you'll note is that you subclass component. We have a handler decorator, so we define an event handler called read, and we basically throw back at the client the data that we received. Instantiate this component and run it. So as circuits is event-driven, and supports asynchronous I/O, it obviously also does have an event loop. So when you run components, it runs the event loop, knows about all the other components that have been registered in the system, and these components start interacting with each other. So if I can just go back to that previous slide, one of the things that we've done in circuits for a long time is build in some tools that allow you to visualize the structure of your application as you're going along, or just to sort of get a visual idea of how the components are wired up and hooked together and how they interact. So you can see there's right at the bottom there's a select polar. So circuits has a number of built-in polars: select, KQ, pole, and epole. You can select which one you want. Circuits does not automatically use the one for your platform. You've got to sort of explicitly do that. Then you've got your main app component, a TCP server component, and I believe there's a debugger component on the side there as well. So when that top-level component in the graph runs, all of those components interact with each other. I believe that's a bit cut off there. This is what it looks like in the latest development version of circuits. We've just sort of swapped out some of the underlying tools that we've used to generate these graphs. Originally, it was PyDot and GraphViz. I think this is NetworkX and GraphViz and some other Python libraries. It doesn't look that great, so if there are any good UI designers that know how to make these things look prettier, come and talk to me. I think that slide says demos. Just how are we going for time? Probably heaps of time. All right, so let's see if we can do some kind of demo. I believe that works, except that this isn't showing my terminal. Oh no, there we are. It does. If you'll excuse me for 1 minute. Drag it to the screen. All right. There we go. All right, that's better. So that was the example that you saw in one of the earlier slides, just a very simple hello world. The code is absolutely identical. I suppose I can do this. We'll see if we can run the Echo server demo. There was a talk earlier that I attended about live demos being bad. I will try to make these things work. Oops. I believe that's connected on some port somewhere. Let me just check. Port 10,000, of course. Apparently, I can't use Unix. I actually use Unix as my IDE as a day-to-day development, so you'd think I'd be better at this during live demonstrations. So hopefully that has done exactly what we expected to do as a very quick demo. I suppose I have to drag this back to the other screen, don't I? Nope. Great. So just a couple of quick demos, just to show you that it works, and I'm not just, haven't just developed this yesterday. Okay, so the core API of circuits, you've probably seen some of it in the examples from before. So we have fire, call, and wait. These are our core APIs that every component knows about. One of the talks earlier in lesser-known data structures talked about metaclasses. So Circuits does use metaclasses. It uses it primarily to give the programmer convenience. So every component that you subclass from component, every method basically gets automatically decorated as an event handler. In some of the examples I showed you before, we also have the @handler decorator. So Circuits also supports both explicit and implicit ways of doing things, just to sort of satisfy both crowds that like implicit versus explicit things. So component registration. So you register components by calling register from one component to another. You can deregister them by calling unregister on that component, which will take it out of the component graph and it will no longer cooperate in events. Some of the convenience that we've also built into all components as well, which I won't go into here, is that components can actually be added together using the @operator and the plus equals operator. So we overloaded those in components so that you can basically compose components in sort of a very nice syntactic sugar sort of way. So these are the ways in which you spin up your component graph, your top-level component graph. So typically you register a bunch of components together and you either start that component graph in a separate thread, which isn't typical, but we do use it in the unit tests. You can also use that for interactive shell, register a bunch of components, start them in threaded mode, and then you can sort of play with it. Typically, though, you just run the component on the top level, the very top component. And then you can also call stop on it, which will basically terminate the system. So here's where we are now. Circuits has been developed for over 10 years. So we have our core API. We have our core components. So base component, debugger. We have a daemon component in our application namespace. We did have a few more, but they kind of sucked a bit, so we removed them in the latest version. They weren't very asynchronous. We had a configuration component, but it's sort of just wrapped around config parser. Yeah, anyone can wrap around config parser. We have a whole bunch of I/O components, as you'd expect. So we have a file component, serial component, and also the iNotify component, which only works on Linux. So if you try and do this on OS X or Windows, the import won't be available. We have a whole bunch of networking components, obviously. So Circuits does have a whole built-in component library. So we've got Unix server sockets, TCP sockets, UDP sockets, all that sort of stuff. One thing to note about Circuits compared with something like gevent is that we don't monkey patch any of the standard library. So these are all independently developed components. Bear in mind, though, that we didn't really largely write a lot of the polling stuff. We borrowed from other people and tried to learn from the best of libraries out there. So a lot of the polling code was actually borrowed directly from Twisted. So sorry, Twisted developers. It just means that stuff works as expected. We don't have very many protocols. I did mention before earlier that there is a little bit of work that I've done a little while ago to integrate Circuits and Twisted. So Circuits can run Twisted protocols, and I have tested this. And there's it's in the Circuits repository on Bitbucket. I haven't published it yet. I think I feel that probably more work needs to be done. Needless to say, Circuits doesn't have very many protocols. We have web protocol, IRC protocol, HTTP, line protocol. That's about it at the moment. One of the things that I've found frustrating about writing little web servers, little socket servers that do interesting stuff is that a lot of protocol libraries and a lot of libraries that handle various protocols aren't very framework agnostic. One of the ones that I have found that is, I think it's called DNSLib. So there is an example of circuits using DNSLib to basically be a DNS resolver. But a lot of libraries don't really work that well with other frameworks. I think you probably see a lot of new async stuff hitting the Python package index, at least I have, so lots of people porting a lot of protocols to Async I/O. So Circuits also has a web framework. Justin Grigori uses it a lot. I use it a lot as well, so we kind of try to eat our own dog food as such. A lot of Circuits web components were also borrowed, so we didn't really write a lot of this from scratch. It is WSGI compatible, so we have gateway and application, so we can graft things like the Mercurial HG dir onto a Circuits web application. We've got various RPC components, various ways of routing URIs to controllers, all that sort of stuff. It works pretty well. I've used it in production quite a lot for various projects. It could be better. Everything could be better. So this is sort of where we want to go. It's been around for a while. I'd certainly like to see more interested persons, more developers, more contributors. We'd like more protocols, better documentation. Maybe more application components, bit of a better website. These slides are actually on pycon.circuitsframework.com. Circuitsframework.com is actually the website for Circuits. It actually uses the content management system that I wrote in Circuits itself. All of my websites do, but forgive me, it doesn't look very pretty. It looks pretty plain and boring. So here's some of the ways that you can contribute. We have a Circuits channel on Freenode. It sees about 30-odd people quite consistently. That's where we discuss and do most of our main development. Contribute bug fixes, improvements, pull requests. Our repos are hosted on Bitbucket under the Circuits team. Start using it in your projects. It's a framework. It does do asynchronous I/O, but that's not its key strength. Its key strength is in the architecture and the components, in being able to architect your software in a loosely coupled way with better maintainable software. Sort of some of the same arguments as the Zope component architecture. Questions? Thank you. And all right, thanks.
Can you talk a little bit about the tools that you've got to debug what's going on when, let's say, you're using a web protocol and a request arrives and then there's a million different events being fired all over the place across many components? How do you get to understand what happened?
Yep, that's a perfectly valid question. So Circuits is event-driven and has a built-in component called the debugger, which is capable of listening to all events that occur throughout the system. It logs them to standard error by default, and there are also various ways in which you can basically grab those events and log them to something like Logstash if you wanted to. The example I showed before, there was a bunch of stuff being printed to standard out. That was actually the debugger in action.
I've actually looked at the project once or twice, but never quite found out whether it had what I was looking for. Is the documentation one of the parts you think is keeping it from people sort of finding it when they go looking for the Python frameworks?
Yes, I think so. But also I think it's a little bit of the community as well. So Circuits has existed for over 10 years, but there's sort of a rhetoric in the community to use Twisted for all stuff asynchronous. So we don't try and compete on that space. But yes, absolutely, documentation is one of the things that we struggle with, and I think all developers struggle with. We've tried to improve it over the number of years. It's a lot better now. It's on Read the Docs, so circuits.read the docs. Thank you. Any other questions? So the question was, why did we drop the configuration component? The reason we dropped it was one of the things that we like to do in Circuits, because we do natively support asynchronous I/O and Circuits is inherently event-driven. I really wanted a configuration management component that actually supported asynchronous I/O. So in future, perhaps maybe we might reintroduce it, but actually wrap around the file component rather than just wrapping around the config parser, which might actually block your event loop.
One more question. What is the main selling point of Circuits over Twisted?
Sorry, the main?
The main selling point of Circuits over Twisted. How would you pitch that to someone who considered using Twisted for a project? How would you differentiate yourself?
Yeah. OK, so those of you familiar with Twisted are probably familiar with deferreds and callbacks and urbacks. Circuits doesn't really have such a notion as such. We use promises, and we also support coroutines. There aren't really urbacks and callbacks. They are sort of semi-supported, but anyone that's used Twisted, eventually your urbacks and callbacks and your chain start becoming very long and convoluted and becomes very difficult to debug. So Circuits wasn't designed to use deferreds as such. A lot of people that do come to Circuits from Twisted often say, and I quote, that they find it rather elegant. So I take that as a bit of a compliment. But I think that's the main selling point. If there are no other questions, thank you very much.